Hi, I'm an old guy and I do maths. Today we have a bearing problem and we need to know the distance. We need to find out the distance between A and C. Now, we do have some bits of information which I can add in here. This angle here is 78 degrees off north. And this angle here, although it doesn't look like it, is 25 degrees off north. So the true bearings are 25 and 78. This is not drawn to scale. We also know that the distance from A to B is 5 kilometers and from B to C is 6. So I guess that if when we're going to play fast and loose with the rules, how far is it from A to C? Well, you could go up here via B and then on to C. But what we're actually looking for is this distance here, which I'll just put in red. I'll just put a red dotted line in here so that we can see what it is we're looking for. We're looking for the most direct route, giving us the shortest distance from A to C. I think that's what the question intended. Otherwise, it seems pretty pointless. Now, in order to do that, we need to know what that distance is. The distance that C is north of A, and we need to know this distance here, the distance that C is to the east of A. Okay, so how are we going to do that? Well, it's going to take a little bit of work. I probably need another piece of paper. The first thing I'm going to do is I'm going to work on this triangle here. So I'll just draw that really quickly here. We know that that's 5, we know that that's a right angle, and we have an angle in here of 25 degrees, which means that we have an angle in here of 65 degrees. Now that's important. So I'll just pull that to the side, and you can see that I've just done a rough sketch here. I've got the 25, I've got the 5. This piece of information is important because I'm going to use this and this to find this and this. Okay, so how do I do that? Well, it's our old friend SOHCAHTOA, and what we know is that if we want to find x, that's the opposite side to this angle, so we're going to be using a sine. So the sine of 65 degrees is equal to x over 5, opposite over hypotenuse. So x is going to equal 5 times the sine of 65 degrees. So, time for the calculator. 5 times sine 65. That gives me that result there, 4.53 we'll say. 4.53. This is kilometers. So these are measured in kilometers. So that's x. Now I'm going to find y. Now we'll use a cosine for this because we have an adjacent and a hypotenuse. We could also use a tangent because we now know this measurement here. But we'll use a cosine just to break up the boredom. So the cosine of 65 degrees is equal to the adjacent over the hypotenuse. So that is, y over 5. So y is equal to 5 times the cosine of 65 degrees. Let's find that for you. So 5 times cos 65 is 2.11 kilometers. There you are. You can see I'm rounding to two decimal places. Just get the lighting out of the way. Okay, so what we know now is that is 2.11. That is 4.53. Just bring that into focus. And that is 5. Now, we don't really need that anymore. What we've got is we've got a measurement here and a measurement here. So if I go back to this drawing, we know that this is 2.11, and we know that this distance here is 4.53. So I can write those in there. Now, the next thing we're going to have to do is figure out what we're looking at here. So, excuse me while I get a fresh piece of paper. And again, I'll just draw this roughly with the information that I have. We know that that is 6. We know that that's a right angle. So 6 and a right angle. And we know that we've got 78 degrees there. So to bring that to 90, because this is due east, we're looking at 12 degrees. Okay. 78 plus 12 gives us 90. Right, so SOHCAHTOA again. And away we go. So, let's find this. And then we'll find this. Okay, so that's an opposite, that's a hypotenuse, so the sine of 12 degrees is equal to x over 6, so 6 times the sine of 12 degrees is equal to x. Okay, into the calculator with that. 6 times the sine of 12 degrees is 1.25. I've done some rounding, you can see that there. Just keep the light out of the way. So that is 1.25. So we can add that, 1.25. We're doing this all to two decimal places and rounding as we go, which is not ideal. I'm much more interested in the method here than absolute accuracy. If you were doing this for a school assignment or something like that, you would keep as many decimal places as you can, unless you were maybe told to find it to the nearest kilometre or something like that. Okay, so the next thing that we need to look at is how we find y. And just for a bit of variety, we're going to use a tangent. And so the tangent of 12 degrees is equal to this over this. Now I'm going to go back to my calculator and use this entire number. 1.247470145, and this is going to stop a huge variance in this. So that is that's a 1.2 there. So opposite over adjacent gives me the tangent of 12 degrees. Okay, with a little bit of algebra here, y is equal to 1.247470145 over the tangent of 12 degrees. Okay, I'm going to divide that by the tangent of 12 degrees. Let's see what we get. And we get 5.87, so I am rounding again, 5.868, 5.87, I beg your pardon. So that is 5.87. Go back to our original page. We've got the information from the first and second calculation on this. We've got the first calculation on this triangle here, and the next piece of information is that this is 5.87 kilometers. Now, we're not done, but this just got quite a bit easier, because from this we can construct a single big triangle, and this is 1.25. Remember that I've done a lot of rounding here, plus 4.53. So that plus that gives us the height, and this plus this will give us the base of this thing. So that's 2.11 plus 5.87. Right, let's get some numbers for those, and I think we could, if we want. Well, there are all sorts of things that we could do, I suppose. My sense is that it's not worth finding this angle using a tangent when we've got this and this, and we're actually looking for that. So I'm just going to use Pythagoras. So 1.25 plus 4.53, 1.25 plus 4.53 is a total of 5.78. Along the bottom here, 2.11 plus 5.87 is a total of 7.98. So 7.98 squared plus 5.78 squared is going to equal x squared, that thing across there, the hypotenuse. Okay, 7.98 squared plus 5.78 squared so that is 63.6804 for that. 5.78 squared is 33.4084. We're going to add those, plus 63.8804, which gives us 97. I'll show you there, 97.2888, and x squared equals that. X squared equals that. So now we're going to find the square root of that. 97.2888 square root of that is 9.86. I'm going to round again. Now, this has been all very approximate because I have been much more interested in the method of how you get from the bits of information that we had here to an answer here for the distance for A to C. As I say, if you were doing this, you would keep as many decimals as you could on your calculator, and that would make this a great deal more accurate than I imagine this actually is. So if you feel like it, you can check it out and see how far out I've come from what should be a better answer by doing all that rounding. But the method was what I wanted to show you, and I hope you found it useful and interesting. If you did, please like and subscribe, and I'll see you next time. Bye.